So, let's be totally honest for a second here. How many times have you clicked forgot password just this month?
Oh, man.
Right. Like, if you're anything like me, you've probably stared at a login screen, typed, I don't know, your dog's name with an exclamation point, hit enter, failed.
Yeah, and then you add a number 1.
Exactly. You add the number 1, you fail again, and then you just sort of surrender to the reset email. It's, we spend so much of our digital lives just trying to prove we are who we say we are. It is this universal, everyday frustration and, honestly, a massive drain on productivity.
It really is. And, the irony here is that the very systems we use to protect our digital identity are, well, they're the exact things making our digital lives so fragile.
Yeah.
The password, just by its very design, is a massive vulnerability. We've tried to patch it with complexity requirements, rotating them every 90 days, which everyone hates.
Oh, the worst.
Right, or adding authenticator apps. But the root problem remains, we are relying on a shared secret.
And that shared secret is exactly what we are dissecting today. So for this deep dive, we are looking at the technical documentation for a platform called VeriLink.
Mm-hmm.
Our mission today is to explore how this system acts as an OpenID Connect or OIDC identity provider to do something, well, pretty radical. The goal here isn't just to make passwords, like, harder to guess. It's to completely eliminate them and manage authentication entirely on behalf of the user.
Which represents a fundamental architectural shift, really, in how the industry approaches security.
Yeah.
The core theme we're exploring in these documents is this massive transition away from an era of managing secrets, where you have to hide a piece of text, and stepping into an era of managing access. We're moving from secrets to tokens. It sounds simple, but the engineering behind it is profound.
Okay, let's unpack this. Because to really grasp how VeriLink kills the password, we have to look at the paradigm it introduces. The documentation refers to VeriLink as an identity provider, or an IDP. And as I was reading through their architecture, I realized my mental model of a traditional password manager was just completely backwards for this.
How so?
Traditional password manager is, it's like a massive, heavy steel safe sitting in your house, right?
Yeah.
Storing hundreds of tiny little keys that you have to take out and insert into different locks.
Exactly.
But VeriLink doesn't store keys. It sounds more like a highly connected personal concierge, like a concierge who just recognizes your face, walks you up to the door of an exclusive club, nods to the bouncer, and the bouncer just, unclips the velvet rope.
I like that.
You don't carry any keys at all, and the bouncer doesn't even need to know your name, just that the concierge vouches for you.
That is a highly accurate way to visualize the architecture, actually. To use the exact phrasing from the source text, VeriLink positions itself as a password manager for the passwordless era. But as you pointed out, instead of locking away user credentials in a vault, it stores and governs OpenID tokens. When we talk about an identity provider, we are fundamentally talking about a delegated trust model.
Okay, a delegated trust model.
Yeah. The application you want to use doesn't want to do the hard, risky work of securely verifying you. It doesn't want to store cryptographic hashes or manage password reset flows. It just wants the concierge to vouch for you via a standardized token.
And for you listening right now, the reason you should care about applications offloading this work is the direct impact on your personal data security.
Absolutely.
Think about your favorite online store or your accounting software or your productivity app. When they outsource your identity to an IDP, your personal login data isn't sitting in a dozen different poorly secure databases across the internet just waiting for a breach.
Right. The identity verification is centralized.
Centralized, exactly. And the app just gets a temporary VIP pass.
Precisely. We are talking about JSON Web Tokens, or JWTs. When the IDP vouches for you, it isn't sending a password. It's generating a cryptographically signed token. And this token contains specific claims, who issued it, who the subject is, and when the token expires.
So it's very specific.
Very. And because it's signed with a private key owned by VeriLink, the application can verify its authenticity using a public key without ever needing to, contact VeriLink again during that session.
Which brings us to the actual mechanics of how you get that token. Because it's one thing to say, hey, we have a digital concierge. It's another thing to explain how the concierge actually verifies you without asking for a password or, I don't know, an ID card.
Right, the actual user experience.
Yeah, the steps. So in a normal world, you type your email into your software and it asks for a password. But with VeriLink, step 1, the app fires a request using standard OIDC protocols over to the identity provider. Step 2, VeriLink fires off a magic link to your email. Step 3, you click it. And step 4, Tokens are issued, and your session begins and is centrally governed. But here is my issue with step 2.
Magic link.
The magic link. Magic links are not new. And if there is no password, isn't that link literally the key to the kingdom? Like, what stops a bad actor from intercepting that email? Or what happens if a user accidentally forwards that magic link to a malicious IT support scammer?
What's fascinating here is how the documentation specifically addresses that exact vulnerability. Because you are absolutely right.
It seems like a huge hole.
It would be. A standard, naive magic link can be highly dangerous if intercepted. It's basically a bearer token sitting in plain text in an email inbox. But the text explicitly states that VeriLink's magic links are device-bound and IP-bound, as well as single-use and short-lived.
I really want to push back on that, though, because any tech-savvy listener knows that IP addresses can be spoofed, right? Or changed via VPN, and browser characteristics can just be faked.
Sure.
So what does it physically and cryptographically mean for this link to be device-bound? Like, how does it actually secure the link against advanced interception?
That is the critical distinction. It's not just looking at a surface-level IP address or a user agent string and calling it a day.
Okay.
When you initially type your email into the login prompt, that request establishes a stateful session context on the backend.
Stateful session context.
Right. VeriLink generates a cryptographic challenge, often utilizing an invisible session cookie with strict secure flags, and it ties it to the exact network and device footprint of that specific request.
Oh, I see. So the email link isn't just a universal key. It's the answer to a very specific localized challenge.
Exactly. When the link is clicked, the server doesn't just validate the random string in the URL. It checks if the click is originating from the exact same cryptographic state and session context that requested it.
Wow.
So if a hacker intercepts that email and clicks the link from a server in another country, or honestly, even just from a different browser on a different laptop in the same coffee shop, the session cookie and the cryptographic nonce won't match the original request. The link is rendered entirely useless.
So the concierge basically says, wait, you might have the right VIP pass in your hand, but you mathematically cannot be the person who asked me for help 5 seconds ago.
Precisely. And furthermore, because they are strictly single-use and short-lived, typically expiring in a matter of minutes, the moment they are clicked successfully, they become completely invalid. There is absolutely zero window for what cybersecurity professionals call a replay attack.
Replay attack, okay.
Yeah, where a hacker captures a valid authentication signal and tries to play it back to the server later. The state has already advanced. The signal is dead.
Okay, that is an incredibly elegant solution to the interception problem. And I want you, the listener, to imagine the sheer convenience of this for a second.
That's huge.
You don't have to memorize a complex string of special characters. You don't need to open an authenticator app and furiously type in a rapidly expiring 6-digit code before the timer runs out.
A panic typing.
Exactly. You just click a link. It requires zero memorization. But because of that deep cryptographic binding at the session layer, it actually increases your security exponentially over a password.
It's the rare architectural upgrade that dramatically improves the user experience while simultaneously hardening the infrastructure.
Yeah.
Usually, in security, convenience, and safety are, on opposite ends of a seesaw.
And this detailed mechanism naturally brings us to the broader security posture outlined in the source documents. Because if you change the fundamental method of authentication, you force the attackers to change how they attack the system. The documentation makes a really dramatic claim here. It says there is no credential surface to attack. It specifies there are no hashes to breach and no reset flows to hijack.
Right.
Now, when I read no hashes to breach, my mind immediately goes to the massive cryptographic vaults companies maintain just to store scrambled passwords safely.
Yeah, the honeypots.
Right. We all know credential stuffing is a nightmare, but usually companies just slap multi-factor authentication on top as a band-aid. What is VeriLink actually arguing here? Are they literally just deleting the vault?
If we connect this to the bigger picture, that is exactly what they are doing. What VeriLink is arguing is that MFA, while useful, is fundamentally a mitigation tactic, not a cure.
Okay.
It's putting a heavier lock on a door that shouldn't exist in the first place. When a platform forces you to use a password, they have to store a representation of that password.
So they have a target.
Right. Even if they use state-of-the-art hashing algorithms like bcrypt or Argon 2, adding cryptographic salts and peppers to make it hard to unscramble, a sufficiently motivated attacker with enough computing power or perhaps future quantum capabilities can eventually crack a stolen database of hashes.
So by removing the password entirely, they aren't just mitigating the attack, they are deleting the attack vector itself. The credential surface simply evaporates.
That's the brilliance of the token model. If a platform doesn't store passwords at all, a hacker breaching that platform's database gets absolutely nothing.
Wow.
There are no passwords to steal, no hashes to run through a cracking rig offline, and equally important is the removal of the reset flow.
Oh, right. Security questions.
Yeah, traditional password reset systems, security questions, SMS backup codes are notoriously weak and highly susceptible to social engineering. By shifting to device-bound links, you remove those fragile backup pathways completely.
And the other piece of this architecture that really stood out to me was the concept of centralized token governance. The text points out that because VeriLink is the IDP, security enforcement happens entirely at the identity layer, not scattered across every individual platform's application programming interface. How does that practically change things for an organization?
It creates a massive operational advantage, particularly when we look at how tokens function under the hood. In OIDC, you generally deal with ID tokens, access tokens, and refresh tokens.
Really?
Let's say an employee's laptop is stolen. In the old model, an IT administrator would have to log into 20 different administrative panels to individually revoke the user's access to their CRM, their email, their accounting software.
That sounds like a nightmare.
It is. It's slow, it's prone to human error, and during that critical delay, data is being exfiltrated.
But with centralized governance.
With VeriLink centralized governance, you pull the plug at the identity provider level. The text explicitly states that a session can be audited, rotated, or revoked at any time from one central dashboard.
Okay, so one switch.
Exactly. When access is revoked, VeriLink invalidates the underlying refresh tokens. So the next time any of those 20 applications check in to renew their short-lived access tokens, which usually happens silently every few minutes, VeriLink denies the request. The applications immediately drop the user. One place to govern, one action to instantly cascade revocation across an entire digital ecosystem.
Okay, here's where it gets really interesting.
Yeah.
Because it is abundantly clear why this is fantastic for user security. And it's clear why an IT admin would love the centralized control.
Sure.
But let's be pragmatic. If a system is an absolute nightmare for a software developer to implement, or if it's financially ruinous for a business to maintain at scale, companies simply won't use it.
No, they won't.
They will stick to the old broken way of doing things. So we need to look at how VeriLink actually integrates with modern platforms and how the economics of their billing model impacts security behavior.
The adoption hurdle is almost always the hardest part of any security evolution. You can build the most secure system in the world, but if it takes 6 months to integrate, it's dead on arrival.
Right. And the source text leans heavily into this idea of zero lock-in. It emphatically states that there is no proprietary SDK required.
Which is huge.
It is. Developers don't have to download and install a bunch of custom VeriLink code directly into their application's code base. Instead, it relies purely on standard OIDC endpoints. They specifically mention standard paths like /oath, /authorize, and /oath/token. To put this in perspective, it's less like custom plumbing and more like universal passport control. Like whether you fly into Tokyo, London, or New York, the airport scanners all read the exact same standardized chip in your passport. Developers don't have to build a custom scanner for every identity provider. They just use the global standard.
That is a phenomenal analogy, and it strikes right at the heart of developer anxiety. Developers absolutely despise vendor lock-in.
Oh, I bet.
When a security company forces you to use their proprietary software development kit, their SDK, you are marrying your application's fundamental architecture to that specific company's roadmap.
You're stuck with them.
Exactly. If that vendor raises their prices, deprecates a feature, or worse, suffers a critical vulnerability in their SDK, untangling their custom code from your application can take months of expensive engineering time.
You're completely trapped. You basically have to rebuild your front door while the house is still occupied.
That's exactly it. But OpenID Connect is a universal open standard maintained by a nonprofit foundation. It is the lingua franca of the modern internet for passing identity securely.
Okay.
When VeriLink exposes standard OIDC endpoints, it means a platform connects to them the exact same way it would connect to Google, Microsoft, or any other standard identity provider. Any developer who knows how to configure a standard OAuth 2.0 flow can implement VeriLink without reading a specialized manual. It drastically lowers the friction of adoption by making it a true drop-in replacement.
And speaking of adoption friction, there's the billing aspect.
Uh-huh.
This honestly surprised me because it directly impacts technical security behavior.
Oh, yeah.
The FAQ section addresses how they charge, and they utilize a model based on active users per 30-day cycle. They specifically state they do not charge per login or per authentication event. On the surface, that just sounds like predictable SaaS pricing, which finance teams love.
Uh-huh.
But there is actually a deep behavioral implication here regarding session lifetimes, isn't there?
There absolutely is, and it's a detail that many organizations overlook until it's too late.
Okay.
When an identity provider charges a business every single time a user authenticates, every SMS sent, every magic link clicked, it creates a perverse financial incentive. The business naturally wants to minimize overhead costs, so what do their engineers do?
They make the logins last longer.
Yes, they configure the application to keep users logged in for incredibly long periods of time. They issue access tokens that last for 30, 60, sometimes 90 days, simply to avoid incurring the cost of a fresh authentication event.
Oh, wow. So just to save fractions of a cent on a login event, you end up with these stale, long-lived session tokens sitting on a laptop. And if that laptop gets stolen or a browser is hijacked, the attacker has a token that is valid for months.
Precisely. It is a massive, self-inflicted security risk driven entirely by flawed pricing models. By charging a flat rate per active user, regardless of how many times that user is challenged to log in, VeriLink's model encourages heavy, secure usage. The business isn't penalized for enforcing frequent, rigorous authentication events.
So if a high-security app, like, say, a financial ledger, wants to require a fresh, device-bound magic link every 2 hours, or demand an active reauthentication every time a highly sensitive database action is taken, it doesn't cost the company a penny more.
Correct. It perfectly aligns the financial model with the most secure technical practices. The economic incentive to compromise security is entirely removed.
That is such a subtle but absolutely critical detail for engineering teams. And it's clear from the documentation that they are building this architecture for a massive scale, too.
Yeah, the enterprise features.
Right, the text briefly touches on those. If a massive organization needs custom token policies, or comprehensive audit logs routed to their internal security tools, or complex multi-tenant identity management, say, for managing dozens of different subsidiaries under one corporate umbrella, they have the back-end infrastructure to support that kind of volume while maintaining the OIDC standard.
It demonstrates that the architecture isn't just an experiment for small startups. The centralized governance model scales up to the enterprise level perfectly, because the fundamental problem of identity management, ensuring the right person has the right access at the right time, only gets exponentially harder the larger an organization becomes. Standardizing that on a token-based, passwordless flow is really the only sustainable path forward.
So what does this all mean? We've covered a massive amount of technical ground today unpacking this documentation. To bring it all together for you listening, VeriLink represents a necessary structural shift in how we handle our digital lives. It's about taking that heavy, vulnerable physical safe of shared secrets and just throwing it out the window entirely. By utilizing universal OIDC protocols, they eliminate the credential attack surface at the root. There are no hashes to crack.
Exactly.
By utilizing stateful, device-bound magic links, they neutralize the threat of intercepted credentials. And by aligning their billing model with security best practices, they encourage active, centralized token governance. It points to a very real, rapidly approaching future where your favorite B2B SaaS applications, your secure databases, and your daily tools will never ask you to remember a password again. Your identity becomes completely seamless, yet significantly more secure.
It is a highly compelling vision of the future, and frankly, a technically sound one. But, this raises an important question, something we have to seriously grapple with as this exact architecture becomes the industry norm.
Okay, what's that?
If platforms successfully eliminate passwords by binding our identity entirely to our specific physical devices and our current localized IP states, what happens to our digital existence in an emergency?
Oh.
You mean when the hardware fails?
Exactly. Imagine you are traveling internationally. Your laptop is stolen, your phone is dropped in a river, and you urgently need to access your accounts from a borrowed computer on a foreign network.
Wow. Yeah.
The IP won't match, the device footprint won't match, you have no trusted session to anchor a magic link to. If the human memory, the simple, albeit flawed, ability to recall a password from your own brain is completely removed from the authentication loop, are we sacrificing absolute availability in the name of absolute security?
Wow. That is the exact kind of tension we have to think about as these systems evolve. Because the digital concierge might be perfect at keeping everyone else out, but it's a terrifying prospect when the concierge doesn't recognize you.
Right.
Thank you for joining us on this deep dive. As always, we invite you to keep questioning the systems you interact with every day, look behind the curtain of the technology that runs your life, and we will see you next time.